Whoops. Forgot to move the microphone. What's up, everybody? Welcome back to another live stream from Scalar Learning. And sadly, the last of the live streams for 2018. What's up, guys? I know I like to usually do these on Wednesdays, but I was actually out of town this past Wednesday, visiting my parents in Michigan. So I'm back in LA as of yesterday. And I wanted to get one of these live streams out, one more anyways, for the year of 2018 and say a little farewell to 2018 once we conclude. So anyways, without further ado, before we do that, let's jump into the Khan Academy SAT problems. So listen, we got a new SAT coming out in March. And for those of you guys who are hopefully now in the zone of celebrating the year ending, that's great. But starting tomorrow or whatever next week, you're going to hit that preparation hard. So hopefully this will give you some guidance along the way to get yourself ready for the next math portion of the SAT. Today we're going to tackle manipulating quadratic and exponential expressions, and we are going to be I'm going to be doing these problems for the first time. If you haven't seen my live streams before, this is all live. This is all being done on the fly. I haven't seen these problems before. I'm doing them for the first time, so that's part of the fun. You never know what's going to happen, but that hopefully gives you a better way of understanding how to solve these in real time by watching my problem solving process. Here we go. Okay, an architect has been commissioned to build a public landmark. She wants to design an enormous parabolic arch, so something like this, right? That's a parabola. The equation is this. Okay, so this is the height, and this is the meters away from the center, which I assume is this. Here's the center. So I assume, sorry, actually not this. I think what they mean is but from the vertex. So like if it's over here, the distance is that. If it's over here, the distance is that, and so on and so forth. Okay. But none of this even matters. Which of the following equivalent expressions displays as a constant or coefficient the distance from the center? Display the distance from the center to where the arc meets the ground. Okay, so let's see. Ooh, this is tricky. I need to think about this for a second. Okay, so we need our distance going down here, right? And, okay, hold on, which displays as a constant or coefficient. See, some of these problems are really hard. I can guarantee you nothing like this will actually be on the SAT. That being said, this is still a good problem to solve in terms of going through the processes. And then when you can get something like this or understand how to do something like this, the actual problems on the SAT will be that much easier. Okay, so let me just try and understand again. Which equivalent expression displays the distance from the center to where the arch meets the ground? So again, okay, so it's a straight down okay, got it. So look, we're assuming that this is a zero value. Okay, and so all we're trying to do is, if this is my, I understand it now, it just took me a second. All we're trying to do is trying to find the vertex. And since this archway is starting at the ground, all we need to do is figure out what the y value is of this vertex, and that should be the distance from the center to the top of the arch. From the center to where the arch. Oh, no. I'm wrong about that. Wait, sorry. The distance from the center, which is right here, to where the arch meets the ground, which is here. Okay, so never mind. So it's the different distance from the vertex, to the to one of the x-intercepts. It doesn't matter which one. It should be the same. Okay, now I got it. So we can use, so if I can find this value and then this starting point, I think we can assume is at 0, 0. So that's nice. We can use the distance formula and we can solve for this. So this is pretty complicated. Let's make sure I'm doing this right. So if I want to find the vertex, what I'm going to do is I'm going to put this in vertex form first. HM equals negative 1/50th. I'm going to factor this out times, let's see, m squared. Do I need to complete the square here? We do m squared. Hold on. M squared plus 200. And so my vertex is actually, because we could call this, oh yeah, sorry. It needs to be m squared. Wait a minute. To complete the square, there's no middle m value. Actually, I think this is fine, because this would just be m. It would be like m minus 0, m minus 0 squared. So this is actually okay. So we can kind of, I'm putting this into vertex form, which is kind of like we go like this. M minus 0 squared. Now this is the same as m squared, okay? But I'm just putting it in the format because then we know that my vertex is at this value and this value. This is my x value for the vertex, my y value for the vertex. So 0, 200, okay? So then, so we know that that is, hold on, that is my center point. But then we have to figure out what these x-intercepts are. Okay, so we can't assume 0, 0 because we're saying here that this value occurs, that the vertex occurs at 0, 200. I'm going to have to graph this in a second to make sure I'm doing this correctly because this is just a little bit off from the way that I would normally complete the square because there's no center, there's no m value. Like there's an m squared and there's no m value, just m by itself. But I think this is still technically correct. M squared, because it'd be m, it would still give you m squared. So I think this works. Anyways, okay, so let's assume that's true. Then we need to figure out this actual value, and we'd figure that out by plugging in 0 for, I'm still going to assume that it's at the ground where it's 0. So I'd have to plug in 0 for this value and solve. So we'd get 0 equals negative 1/50th m squared plus 200. So then it's, let's scroll down a little bit. Then it'd be negative 200 equals negative 1/50th m squared. Multiply both sides by negative 50. And we get m squared equals, this is a calculus, it better be a calculator question, that's 10,000, and then the square root of both sides is 100. So m equals 100. Okay. So it's at 100, comma 0. And then up here is at, oh, wait a minute. How's it positive 100? Oh, okay. So I guess this side, oh, we have to take the square root as it's plus or minus negative 100 because square root of 10,000 is positive or negative. So this value would be negative 100. Let's rewrite this. So it'd be negative 100, and this would be positive 100, 0. And then the vertex is right in the center, but we're still not done. So now I know that this is 0, 200. And then what's the distance from this point to this point? Now we use the distance formula and we take the difference of the x values, 0 minus negative 100, which is 100 squared, plus the difference of the y values, 200 minus 0, which is 200 squared. And this gives us 10,000 plus 40,000. 200 squared is 40,000. Square root of 50,000. Okay, that's my answer. And then they're giving it like this. Wait a minute. Hold on. Negative values of m are to the left of the center and positive are to the right. Wait. The distance from the center to where the arch meets the ground. Well, wait a minute. I just solved this, but they don't want you to solve it. All right, I must have done way too much work. Hold on, let me see what they're talking about here. See, what they've done is they've simply manipulated the expression, which of course this is manipulating expression. So I think I've actually tried to solve, which I don't need to. I'm just not understanding what they want. This one, I'm going to try a different approach now. This one is definitely not right because equivalent, which of the following equivalent expressions displays constant coefficient, the distance? Hold on, let me take the square root of 50,000 and I'll see if I can attack it that way. calculator. I'm going to tell you why, because I just saw in two of the answers constant. So perhaps if I see this constant, 223, nope, I don't see it there. Okay, so let's think of another possibility. I see a 10,000, which I did encounter in my calculations. This positive and negative 100 is the y-intercepts. Okay, but the thing is, this doesn't factor out. Oh yeah, I see. These guys are equivalent. Okay, I'm leaning towards this. The distance from the center to where the archway meets the ground, but this isn't. Oh, I get it. This is just the height, okay? From the distance from the center to where the arch meets the ground. I'm telling you, this is confusing me. So actually, I thought I got it for a second. 150. These two just make no sense. Yeah, that's why I'm kind of leaning towards this. 40 and 40. If you complete the square, then it's 1600. This would be a different expression. Negative 2500. Oh, sorry. Negative 16. Hold on. Negative 1600 divided by 50. 1600. I'm going to tell you what I'm doing in a second. I'm just making sure the C and D are equivalent. 1600 divided by 50 equals 32. So that's positive 32. That still gives you 200. That is equivalent. And then 2500 divided by 50. Darn it. Okay, so they're all equivalent. They all work. And then 168. Where does that 168 come from? See, I think this is wrong, actually. I think the distance, it's either 168 or 150, right? Because they want you to see that this is a constant value that's kind of hanging out here. That is like the height of the archway, something like that. And then if we go left and right, it's 40 to the left, 40 to the right, or 50 to the left, 50 to the right. Okay, before I hit enter. Now, I don't even know if you can, I'm going to just graph this on a graphing calculator using Desmos, because I want this will give us definitively, and perhaps I have graphed it incorrectly in my mind, or kind of as I'm thinking about it. But let's see, y equals negative 1 over 50 x squared plus 200. Okay, so let's see now if my thought was correct. No, see, what I said was right? See, it goes to negative 100, positive 100, and a height of 200. It's exactly what I said. And then I said the distance from here to here is the square, is, what is it, 223. I must be misunderstanding. Hold on, 223. I must be misunderstanding something in this problem. Hold on, let me read it one more time. The equation that models the height of the arc m meters away from the center. The height of the arc. Okay, right? M meters away from the center. Boom, boom. Showing equivalent expressions displays as a constant or coefficient. The distance from the center to where the arc meets the ground. The distance here to where the arc meets the ground. But see, this is the distance from the center, yeah, to where the arc meets the ground. Okay. All right, I'm going to go with randomly C, and let's see what the answer. It is A, darn it. I should have stuck with my gut. Okay, let me read this because I really want to understand what's going on. So there's a difference of two squares we can factor. This makes no sense to me. Yeah, you can factor it, and that's fine. I don't see how that gives the I am anti this question. I think this question is ridiculous and is poorly worded. I mean, all of these are equivalent to this expression above. I do not understand why this is the distance from the center to where the arc meets the ground. This makes no sense to me. Unless if you're talking about 100 and 100, if you're talking about the center meaning down here, yes, this is 100 away and 100 away if that's what it's talking about. But that's not the center of the arcway. Okay, that's probably what they meant. I really don't like that question. That upsets me. Because the thing is, these questions, as I've mentioned before, now they start to deviate from the College Board standards, because I went to a talk on this a while ago, and it's written strictly from Khan Academy folks, and sometimes that happens. They're not exactly up to the standards, I guess you could say, or whatever. Anyways, all right. Let's try to do better on this next one. But like I said, doing these for the first time, so that does happen. The following function models the amount A of titanium 44, okay, whatever. Which are the following equivalent expressions? Because again, we're going for equivalent expressions. We don't need to understand this usually so well. Which of the following equivalent expressions shows as a constant or coefficient the amount of titanium in the sample 3 years prior to initially measuring the sample? Okay. So it would be 3 years prior. Hold on, let me think about this for a second. So after T years, so we'd have, I think it's this. I think that's 3 years prior, because at T equals 1, that's 1 year, whatever, after. T equals 2 is 2 years, so on and so forth. T equals 0 would be at the time that it's measured, which would be 95. And then to go backwards in time, we'd say T minus 1. That'd be minus 1 year, right? T minus 2, and then T minus 3 would be 3 years prior. So it makes sense that it should be A. None of these other ones seem to make much sense. So let's go for it. What? It's B? T plus 3. Oh, shoot. I should have known that. Okay, now I know why, actually. As soon as I realized. It's decreasing. Sorry, so as T increases... wait a minute. T after... Hold on. 3 years prior. So if it's... Oh, I get it. No, wait a minute. And the sample 3 years prior to initially measuring the sample. See, again, if I'm measuring it at 4, right, at 4 years after, I'm thinking T minus 3 would be 1, and that should be 1 year. Oh, hold on. That would be 1 year after, in a particular sample after T years. So if T equals 1, that's 1 year after. And then T equals 4, that's 4 years after. So it's like, to go back to 1, right? We should be subtracting 3. Okay, this one actually doesn't make sense now that I think about it. Hold on. T plus 3 equals 0. T equals negative 3. We determine a value by elimination. So 3 years earlier, there would be more of it, right? Exactly. Measuring the sample as a coefficient. 3 years prior. T plus 3. Did they change the... Oh, they changed the coefficient. I didn't even see that. Okay, so they were modifying... Okay. These are really hard problems. Or hard or poorly written. I can't decide which. But I didn't even notice that they had modified this. They had basically changed this to modify that. And then now this is the sample. Okay, so now I get what they're saying. We should have more of the sample earlier. This is less of the sample. That's what they're talking about. Totally missed that. All right, this is the worst I've ever done. So far 0 for 2. Let's keep trying. Okay, a train traveling at a speed of s miles per hour applies its brakes before a buffer stop. Assuming d is greater than or equal to 0, s is greater than or equal to 0. The distance d in yards from the train to the buffer stop once the train comes to rest is this. Which of the following equivalent expressions for d contains the traveling speed of the train? Which of the following equivalent expressions for d contains the traveling speed of the train for which the train rests right at the buffer stop after applying its brakes? Let's see. To think about this. So hold on. I have to read this one more time. Assuming d is greater than or equal to 0, the distance d in yards from the train to the buffer stop is that. Okay. For d contains the traveling speed of the train, and that's s, right? The traveling speed of the train for which the train rests right at the buffer stop after. Oh, okay. So we're saying d is 0 because that's right at the buffer stop, right? So d equals 0. Okay, hold on. Let me think about this for a second. Yeah, I think it's okay. It better be right this time. I think it's this one. I'm going to tell you why now. Okay, so they're basically saying we want to see the value of s where d is 0 because they're saying it's right at the buffer stop. D is supposed to be the distance to the buffer stop. And so we're saying d equals 0 equals 0.5 times all of this stuff minus 1.2s plus 184.6, okay? And then now since we're setting it equal to 0, we want to factor this guy. Well, we can't factor it like this. So first we're going to distribute actually, no, we can leave the 0.5 out. We can just factor what's inside here. Let's pull out a negative 0.5, and that becomes s squared plus 1.2s minus 184.6. Should be easier to factor that way. And then we would have, let's see now, s, so it's plus minus, so it's plus minus. All right, so what two numbers, actually, I'm going to just look at the answer and test those numbers, see if that's right. So it's a positive 14.2, which makes sense, and a negative 13. This is a calculator question, so I'm going to do 13 times 14.6. 13 times 14.6. Make sure that works out to be 1. Oh, wait, did I write that wrong? 13. Oh, sorry. 13 times 14.2, and that's 184.6, which is that constant. Okay, so that means this is correctly factored, which means that s is going to be 13, right? So that's the speed. It's going to be 13 in order to stop right at the buffer stop. All right, come on. We can't be 0 for 3. All right, there we go, 1 for 3. God, these are brutal questions. I can say with almost 100% certainty, probably 99% certainty, you will not see something like this to this level of difficulty. I can see them wanting you to factor and so on, but these are quite difficult. Okay, a banking firm uses a particular algorithm to create models given a number of data entries n. The algorithm's delay, d's, blah, blah, blah. For how many data entries does the algorithm... Okay, so now we're actually solving, so it'll be easier. For how many data entries does the algorithm have the least delay? So you have to understand what they're talking about. And again, we're talking about a parabola, and it's going up like this because it's positive right there. And so we're talking about just finding the vertex. And look, this is already in vertex form, which is really nice. My vertex is occurring where n equals 45 and d equals 450. Because in vertex form, I know that this value, when it's being subtracted, is the x value of the vertex. This is the y value of the vertex. So for how many data entries, and n I assume is the data entry, right? Data entries n. Yeah, it should be 45. Okay, make sure I'm not rushing to judgment here. If I think about 45, I'm plugging 0, I'm getting 450, yeah? If I plug in, let's try 43, that would be to, yeah, whatever. It would always go up because this value is always positive, so it's going to give you something. It's going to be going up on both sides. Let's see if that's right. Good. Okay. Last but not least, the cereal company wants to enlarge the volume of the cylindrical container used for one of its products by enlarging the radius of the cylinder. Okay. Here we go. The height must be 20. I don't even know if I need to draw this. I just do it as such an instinct. The height must be 20. The new volume of the cylinder is given by this. All right. Where x is the additional length of the radius in centimeters. Oh yeah, because let me try and think. Volume of a cylinder is pi r squared times height. So this is the radius squared, of course. That's the height is 20. All right, cool. Which of the following equivalent expressions displays as a constant coefficient? And they missed a comma, right? Every other time they put a comma there. Constant or coefficient, the present value of the volume of the cylinder. What? The present value. Okay, let me read this one more time. Cereal company wants to enlarge for one of its products by enlarging the radius of the cylinder. The height must be 20. The new volume of the cylinder, where x displays as a constant or coefficient the present value of the volume of the cylinder. Okay. Present value. And let me put this expression down here. V equals 20 pi times 5 plus x squared. Okay, let me think about this a little bit more. The present value of the volume of the cylinder. Uh, 500 pi. Hold on, let me think for a second. What do they mean by present value? Do they mean, oh, I think I know what they mean. Got it. Okay. Trying to decipher what the heck they're talking about in these questions. I think what they're saying is right now, before they've done any enlargement. And what is that value? Well, right now, since I haven't enlarged the radius, that my x value is 0. So it's just 5 plus 0 squared. So 5 squared is 25 times 20 pi. 25 times 20 is 500 pi. And so that's the present value of this volume. So like a really convoluted way to say that. So my assumption is the only one where I see 500 pi is in this one. I also see it here, but let's just make sure that this is still the correct expression. So if I were to, here, let's FOIL this guy and see what we get. So this becomes 20 pi times 25 plus 10x plus x squared. And then distribute this like this. And we get 20 pi x squared plus 200 pi x, plus 500 pi. That's if I distribute this. So I do get that. So I'm just going to try this and see if that's right. All right. My God. All right. That was pretty brutal. So anyways, very difficult questions. I'm going to see if I got any questions. Hey, what's up, guys? Hey, man, just wanted... oh, wow, that's amazing. 770, that's incredible. Congratulations, Adam. Hope you're still on. That's amazing. Yeah, these are crazy. They're all correctly factored. It states that they're all... Yeah, you're right, Daniel. I think I just missed that. These were tricky for me. Hopefully they're easier for you guys. Okay, so listen up. Thank you guys so much for watching. Here's the thing. It's the last few hours. I think we got, in California, we got 7 hours left of 2018. And I just wanted to thank all of you guys watching and supporting the channel so much. And it's been a great year for me, really, really great. I've seen a lot of growth in my in-person tutoring business and on my various social media channels. Also, my Instagram has been doing great. YouTube, especially for all you guys watching and commenting and liking and helping my channel grow. I mean, it's almost tripled in size in the last year, which for me, it's huge. I mean, I know I still haven't even reached 3,000 subscribers as of today, but it feels like a big accomplishment for me from starting this way back 2.5 years ago, and all the comments and support. So I really appreciate it, and thank you guys so much. Whatever your goals may be for the new year, I hope that you guys are able to write them down, think about them carefully, and go out and achieve those goals. I know I'm going to be doing the same thing for myself. I've got a bunch of goals in mind, and I want to work really, really, really hard in 2019. That's something I pride myself on, is my ability to work extra hard, hopefully harder than anybody else, is the way that I always look at it. And I hope you can do the same thing too, because it feels good to work hard and be able to accomplish and sit back and say, yeah, I did that, and I did that because of grit more than anything else. So that's it. And again, it's been a great year. Best of luck to you guys out there preparing for the SAT. And we got lots of great content coming at you in 2019. Best of luck and take it easy. Happy New Year, everybody.